here is the moment of truth. I made this module here, make abstraction of everything that is here, and I will link two wires to those two diodes there. This is the actual circuit module board, the two diodes that will stay on the 4 data line. One line exactly like there, exactly like here, how it was built, that one. I will make a micro, a mini module like that here. Positive rail on the top, data rails, 4 data rails here, on which the diodes will get the input. And pretty much these are 3 resistors, 1 kilo, 10 kilo on the base of the transistor. That is the collector of the transistor, and this is the emitter, because this is an NPN. Also, this pad here is the output there. This is the LED, positive leg, negative leg to the ground, and 10 kilo from this pad to the ground. So pretty much this is the circuit. In the original design, I put 10 kilo on the LED itself, but it does have this 1 kilo already here. And as you can see, the LED is staying lit, not really super bright. Probably I will use 470 ohms, not 1 kilo that I'm using right now. There, especially for the LED, because this is, the output should be actually 5 volts here, and it's fine if it's a little bit less than 5 volts. The output will go to this chip, or if it's not used this chip, then the L298 that I'm having here, motor driver. So that's the output. But for now, I'm testing the LED and how everything is behaving. If it's impeding, if it's obstructing anything there, and I did already the test, and it's absolutely fine. So pretty much this is the circuit that you see here. It's here on the breadboard. I wanted to make all 4 of them. I said let's test first one module to see how everything is going, and it's good enough. I trust it will work with everything else. I don't have to really make all 4 of them. I hope you can see good enough. I will use wires, only wires I will use. So I'll have to get under this resistor here and put it. Right now is only, if I'm making a stable contact, only one, this LED, so check this out, only one, this LED is lit. Here, I hope you can see it because there are some wires here. So only one, this LED is lit, this one will not get lit. It will stay, will get off when this guy will stay on. And when these 2 LEDs will stay on, or one of them will get on, the LED, this LED here will stay off on either of them staying on. So this is, you see, and you can count there. You can count there. This LED will stay on only when the last 2 of them are on. But when one of this guy are on, this guy will stay off. When I'm connecting both of the wires here, and I will tell you when. Now, now. So now you see. Let me actually lower the speed a little bit more to be more clear, because I've seen it myself in high speed, and this is how it's working. When one of them are staying on, this guy is staying off, and it's absolutely gorgeous. I love it. I love it. I'm really happy with discrete component logic so far. I mean, I got a lot of. I'm starting to trust it more and more as an alternative to the wicked chips that I have. And voila, this is it. This is the test. Of course, I can use whatever wire I have, because this will be connected, these diodes will be connected on either of those wires in a specific logic. I showed this logic in the Proteus diagram. I've also made a new simulation with this arrangement that I have here, without that extra 10 kilo that I had before on the LED itself. And it's absolutely working fine. Also, it's working fine in reality. These are the LEDs that I'm actually using, the old type of LEDs. It will be big, but I don't think it will be bigger than this. I'm really upset that I couldn't make it work. I was thinking only on the inputs of this chip, absolute 0 volts, absolute 5 volts, and I was concentrated on how to do this arrangement here with these components here and everything. But I didn't think more in advance how the signal will come. And I was thinking that I can ground easily. I can put a pull-down resistor to ground on this basis, and I will bring to ground to give an absolute 0 volts signal, pretty much, until the positive signal will come to the respective pad base of the transistors and then activate it. But it didn't work. Absolutely didn't work. Or the chip itself it's so extra mega sensitive. It's way too sensitive for these guys. Probably I have no idea what is going on and how to. But I will definitely take out some components from this board. Or I will leave it as it is right now, and I don't know. But it is a busted. It is a wrong circuit what I have here. Totally wrong. It didn't work at all. And I'm very upset with it because I spent so much time on it. It took me a lot of work to make it, and yeah, it's not fun. Yeah, well, this is probably my first fucked up board that I fuck it up. Final board. I mean, usually I'm doing it here on the breadboard. Usually, all the time I'm making, because here on the breadboard I can very quickly change the components between them and find solutions. But here I cannot do that. It's not easy. It's not easy to change anything here. This is finite. You know, it should work first here, and then after I check it here, then here should work as on the breadboard. And usually it does. But this guy just fucked itself up by itself while I was soldering, while I was fingering it, putting my fingers on it. Probably, most probably, these chips are very sensitive to electrostatic discharge, and that's the only reason I can think of, really. Because it was good. When I took it out from its box, it was good, and it gave me good results. But yeah, I will not talk about it anymore because it's pain in my soul. Yeah. And but I'm very, 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 very happy about this little module here. So like this, you know, like this module here is absolutely brilliant. I love it. I love the how it works, and I'm very, very, very sure it will work fine after that. I should actually put the input there. Probably. Nah. But that's the idea. This is the idea, and I made the test, and I will start make the board right now. All right. All right. These are the boards already prepared. Manual printing. I print them, but manually. How it's called? Rendering them. You know, I made a bit more explicit board here because I was thinking is not exactly as this one. That's a reminder there to first test it here on the breadboard, and I already did. And now all the boards are prepared, ready for the pads to be glued, most probably glued. But the entire board will be this big, and another board here that will stay at 45 degrees inclination, exactly like this model that I have here, but it's smaller, and it's definitely smaller than this board. Definitely smaller than this board. How small? So probably half of it. Yeah, kind of half of it. Smaller. Yeah, pretty much. If you didn't figure it out already, I already explained here, and it's very explicative as in the first one here. The diodes on this pad. This is a pad. This is a resistor that is its leg is going to positive, going to this pad, which is the collector of this transistor. Also the positive of this LED. Its other pin of the LED is going to the minus rail somewhere. It will float there. This other line is also the negative to this 10 kilo to this pad, and the other pads for the transistor, collector, base, and emitter of the transistor. I didn't put the link from emitter to negative, I suppose. Yeah, directly to negative. I think this should be there. Yeah, let me check it out, actually. And I made a tiny mistake, but important. I had to link this this 10 kilo to this. This is the negative pad, emitter of the transistor, going to the negative pin of the LED there, and then forward to a rail of negative rail link everything. And I enlarged this pad. I made more space. I gave more space for it. Probably is not a good idea to get on the margin here because these boards will be one near each other. But this is the pin of the LED, probably this pin as well, and here forward to a negative rail somewhere there. And that's the correction. And it's very easy to make it, to correct it when I am drawing with, and erasing with an eraser. Here is my, I have this eraser probably 10 years, and it's still soft and very, very erasable, as you can see. You see, it's bendable. It's very, very, very good eraser. I had a very good luck with this. Very good eraser. I had other erasers that they, with time, they became extremely hard, and I cannot use them anymore. But this one, absolutely awesome. So take good erasers that are soft, rubbery, and these are the good ones, not the hard ones that are getting hard very quickly. So pretty much this is it about these boards. I corrected them, and they should be good to go. And yeah, small update. Hello, I hope you like my little turd here. This is actually plastic that is coming from this gun, plastic glue gun it's called. KL1011D, 12 watts, 72, I don't know what this means, but it's the original tube or cylinder of glue, of plastic, hit plastic or something, I don't know how it's called. It's the original that came with the gun, and as you can see, it's very, very yellow because it's more than 10 years ago. Probably 15 or even more than 15 years, and it's solid. It's very solid plastic, but it's how it's called, rubber. It's like a rubber, very hard rubber, which is very good because, and my guess it's made from silicon, or is composed. The composition is having some silicon in it, because I'm actually, this is how I'm working here. I'm cutting a little bit of this material. I'm putting it here. I'm melting it with my iron, which is hot at this moment, and is alive, very hot, and I'm melting it and put that pad there, and but it's looking very, very weird and very, very strange because I had to take it out from the gun itself because I push it so far into the gun, and usually you take a new piece, you push the old one with the new piece, but I didn't have the new piece, so I had to power up the gun, to heat up the gun, and let it pour down from behind, and I actually grab it with a tweezer, and that's why it's looking like it is. But I wanted to present it as well. It's a good, very, very good material to stick to stick my pads here, to glue my pads with heatment. I put heat on it, and I put the pad, and of course when you have to solder the component, it will start to move around very easily, like it's on water. But after, if you are careful and you know exactly what you want to obtain, and you know exactly what you want to do, it's good enough. And when it's not hot anymore, and when it's cold, it's rock hard, almost rock hard. And the adherence from the cardboard and the metal pad that I have here is absolutely extremely good, and it's catching very well. And right now I wanted to present the fact that I finished the pads. I put the pads on the boards. On the next, only one bent here from this long one. I cut them a little bit too long, and I bent them all but the rest are not pushed through the cardboard, are only glued there. So remember, silicon based materials, they perform absolutely fantastic when they are heat up, and when they became cold, they are rock hard, pretty much. And the adherence is absolutely fantastical. It's very good adherence, and the gluing properties are very strong, and it's good enough for what I'm doing here. It's absolutely fantastic. I had to experiment a lot of stuff, but until I figured out this composition of silicon, the silicon composition. So pretty much this is it. Next, I will have to add the components themselves, and also the board at 45 degrees that will sit here, and it will look pretty much like that, except the fact that all those red transistors, I don't have any more transistors like those. I've actually used them all. I didn't have red ones. I had two yellow ones, and that's it. I don't think I have any one left like that. I use them all only on this project, and I'm very happy because I reuse my old components, my old scrapped components. But here I will probably use, as I draw already, this square here is the transistor space or head, and the legs there, and it's pretty clear what it will be. Probably I will use these fucked up diodes. I don't know, because I really want to get rid of them all. Right, pretty much this is it at this stage. I made the boards, and yeah, see you later. Давно матисти фотом пизда. And I filmed it and I was talking without filming it. Unbelievable. So what I have here are these modules, and I made like a fence. This thing here is plain paper. It's nothing fancy. Used paper. Here it says lumina in my language. It means light in English. So this little fence is, like I said, from plain paper, not from cardboard, because it is good enough. It is protecting these boards here from shortening. Here, if I'm putting them very close together like this, it is possible. I hope not, but let's not hope, but be sure that this side of the circuit with that side of the circuit will not even short together. Here is the positive rail, plus 5 volts, that is passing through this 1 kilo resistor, also that one, and passing to this pad that is connecting the collector of this transistor and the positive leg of this green LED here. And here on the other side, on the other circuit, this pad is the negative rail. And this part, it doesn't matter, but here is absolutely the negative rail. And if this side of the circuit with that side of the circuit will touch each other and will make a short, it will not be a catastrophic short, but it will not work. This circuit will not work because it will get shorted there. And well, I don't want that. I was considering having a distance between the pads like this, a visible, clear distance. And then I thought even more, and I thought I think even more, and I thought, well, maybe if I'm making this kind of a fence, very cute fence that I have here, and it's eliminating that dead space that I have in the first version there, and it's keeping everything very close together as I wanted. And this should be on top like that, because these legs will be linked together. They represent the negative rail, plus another wire here and another wire there, like that, to the negative. And pretty much the boards are almost done, By the way, the components are mounted already, so yeah, I hope you like it. I personally really like this solution. Very cute. Thank you very much. So here is mounted with this guard. I put a single drop of glue in the middle for each board and push it there. And I've soldered all these legs of the negative rail here. Also these very thin wires, you can see them here, you see it? And also there. And it's almost done. I only need to make this board here. This is a small board that I had it there. And some for reason I didn't use it. I don't remember where I should have put it yet, but it is too small for all these that I have here, all these 4. It's a bit too small, unfortunately. I can kind of, if I really want, I can use this one. I will think about it, or I will make a larger, longer one. But that's the idea. These are the 4 logic lines from all these 4 wires here, from there. And this top line is the positive rail. This will be the negative rail, pretty much like the other one that I made already. and it's almost done. Almost done. All right. We'll see you. So right now I didn't make this board. I only have this sample one that I have here. You see, chocolate. But I will have to make another one, a new one, and mount it here. That's it for this part. Well, I was discussing with my friend, and I made this test and I told him about it, and that is working fine. He was concerned of the output here to that circuit. If it will, it must be minimum 2 volts on the output here, and it should be fine. Actually, it will be 5 volts because or the maximum voltage that the positive rail will have. It will only have a very small current, because it's passing through this 1 kilo here. But other than that, and it will feed directly. So these are the outputs. Here are the outputs for these boards that will go to that chip pins there, and pretty much is 5 volts there. Another thing that he mentioned it to me, to get rid of this old style of LEDs. How he put it, if I remember, screw or something, screw with the vintage look. Just use the high brightness LEDs, the new types of LEDs. And I'm totally agreeing with him. But well, this is a vintage. It must be a vintage look and feel, as shitting crappy as it is. I really dislike these old types of LEDs. The technology in them, they are looking nice and almost new, but the technology they used, it's very meh. I am a pro. And I love very much the high brightness LEDs. So what I said to him, the new LEDs are not current driven anymore, like these old types of LEDs were in the textbooks. These are current driven LEDs, but the new types of LEDs, and what I'm talking about are these. I can actually show you. Are these guys? 80 milliamps? No, not really, because well, I tested them. I don't know what tests I did, but I know I put they are working with 1 kilo, with 10 kilo, and even with 100 kilo, if I remember right. So at 100 kilo for 5 volts with 100 kilo on their legs, the current is absolutely infinitesimal, and they are still bright. And but these guys, they don't work with these guys that I mounted here. I've already put 1 kilo here, and they will be somewhat lit up. If I will not be pleased with the level of brightness they have, I will have two possibilities. Either I will change this 1 kilo resistor that I have already installed there, or I will change the LEDs with new types of LEDs, the super bright ones that I have here. I'm also having a ton of 5 millimeters ones, but I really like what I truly like are these 3 millimeters ones. I'm a fan. They occupy a little space, and they are as bright as the 5 millimeters, and I also have other colors, as you can see, greens, blues, yellows, and reds there, and also white, very bright white. It's cold white, it's not warm white. Also for this are also called white, but they absolutely they are fantastic for current. They practically they are almost not eating any current at all, very infinitesimal current. And my friend from England, he told me that he managed to drive a super bright LED like this to drive it only by touching its leg while it was grounded, and it lit. It started to lit and quite good enough, quite bright. And they are absolutely fantastic for, especially for logic stuff that I have here. Right here, what I'm doing, I'm pushing the limits, if you want. This is actually real electronics that. These are very hard, not very hard, but they are quite hard to include into logic stuff, and to actually make everything work with this kind of power hungry, a little bit of power hungry from the level of currents that are moving around these gates and bases and transistors here, these logics. And yeah, pretty much I will see. I am confident it will work fine with what I have already here. The only thing that I can actually make a test right now. I can put 5 volts here and negative here and see exactly how bright they will be. But should I? Yeah, I can. Yeah, let's see. So this will be the negative. On here on the LED. Yeah, it's acceptable. It is acceptable bright. It's not that bright, but yeah, it's kind of dim, but it's not really dim. You can see it, and even from a steep angle like that, it's good enough. And if I'm testing them right now, I will test them all actually to see if some funky business, but no, it's not funky business, it's good enough. So it's pretty much what I'm doing here. I'm powering this LED directly from 1 kilo directly, so positive 1 kilo LED and negative. This is it. It's that simple. And the rest of the circuit is not actually doing anything. This transistor will surge the current from the LED when this will be positive here. Will power the gate, not the gate, the base of the transistor, and the transistor will open and will surge to ground the current that is passing through this 1 kilo, thus powering down the LED. And so it must have both of them powered. These inputs here powered with 5 volts, or with some voltage here to to activate the the base of the transistor. Pretty much, this is it. Yeah, a little bit of test. What I really wanted to show you was the how I glued everything and how it's looking with the guard here, with the paper guard that I make. And also I put those wires, very thin wires, and pretty much this is it for this part. And I have to put this, to create this board as well. See you later. Right, alright, and rails are done, are made. So this side of the board, of the cardboard, as you can see, it's black on the other side, will be glued to this side here that is unfortunately plain paper that is flying around. Not that good. I should probably put some glue under this paper to those boards there as well to strengthen it a little bit better. But pretty much this is how it will be here. And it's almost there, almost done. Yeah, I'm very happy, I'm very pleased how this came out. How I'm very sure that this will stay put and not move around. What I did, I used this plier and I press them like this back, you know, and pressing them like this, like in this manner back. I started with the last one and continued to the top. So first 2, 3, 4, and the 5th, and I pressed them each and mounted the another one and so on. And they are looking okay. They are looking very good. Like I said, I put there a positive sign for the top rail, and the rest of the 4 are the data rails, pretty much, and it will be awesome. And it will stay like this at pretty much at 45 degrees, something around 45. I don't really care, but yeah, to be inclined, that's the idea, you know. Okay, we'll see when I will actually glue it and then probably even solder all these beautiful diodes. I hope I will not get fucked by them because they are special diodes. They are pointing like that towards, as you can see, a little sign there. You see it? Of the diode. The blue dot on the diode is the positive, not the negative, as usually is on every diode. So these are special diodes, special scrapped diodes. And they are probably Russian or Romanian, I have no idea, because Russia and Romania, they were friends some not far time ago. We were brothers, but today not anymore because capitalism, you know. But yeah, pretty much this is it. Yeah, I really hope it will work. See you later. And the level, I've glued this board to the other boards there. I've also glued the paper that was glued to these cardboards, these modules. So these single modules to that paper that is having with the guard here, and also this diagonal rails. I've also, as you can see, obviously, I linked on the other side, like that, you see, on the back there, where the bend is happening of the rail. I put the wires here, of course in order, and I made a test and it's working absolutely fine. This is the negative wire and this is the positive, exactly as I told you. And let me power it on. All right, this was unnecessarily complicated. Very unnecessarily complicated it was to be done. And now it's working absolutely fine with absolutely no problem whatsoever. Also, if I'm switching, because this was actually the problem when I tested with the chip, with the 7432 OR gate. When I was switching, it was having some funky business I was doing. And right now, when I'm switching from here, is absolutely fine. Of course, this is a very low speed. You can actually see and count everything when it's working. And also the direction, which is very important. Now, if I'm switching, you can see that as you can see, the sense is in this direction right now. Pretty much like that, in that direction, and this is in this direction. And when I'm switching it, is that direction there, and here is in that direction. And it's absolutely awesome. Also, the LEDs are okay, how dim they will be lit, but they are not dim at all. They are nominal, you know, not very bright, not very dim. Probably a bit more bright than these ones. These guys here are a bit more brighter than these ones. A tiny bit, imperceptible, but they are okay. They are okay, yeah, and pretty good. I'm very happy with the result. Also, the signal is good enough. We will see how the signal will go from here to there. I didn't put this the wires of the signal that is going to the this current driver that is still in testing right now. The problem with it is that I'm trying to make it a variable current driver to variate the current through the motor, and yeah, I will have to find a solution. I'm pretty much. Yeah, so that's the variable current driver, and that will drive actually the motor driver, which is that L298, and that will in its part it will drive this small motor for the moment. But I have a bunch of them that are waiting there. I'm also having another one which it needs 20 probably 20 volts or something. I had problems because of that. It's not here, it's in the box, but that one will tell how good everything is. And the problem that I have, I will not talk about it because that's completely other subject, and I will concentrate only on what is here right now. And what is here right now is this board that is finished, fucking finally, like I said in the beginning of this little video segment that I'm making right now, absolutely unnecessarily complicated. Unnecessarily complicated. It should have been done very easily with only one chip. It should have been work, but it didn't, and I had to overcomplicate it with this discrete component OR gate, pretty much. But it turns out this is actually a XOR gate. It's not really an OR gate, but it doesn't matter. It's doing the job. Either way, it is good enough. It's fine, you know. And I'm really happy with how it came out. I should now is the case when I should take this and put it in continuation of this board here, and also make a switch between these two modes, because this is one mode of driving a stepper motor, which is called wave driving. This simple way of driving, as you can see it, this is called wave driving, and this is full step driving mode. So these are two modes that I'm having right now. So full step, and then is a third one, a half step driving, and there is a fourth one, and that is called sinusoidal waving. I don't remember, but it's there in the I have to look it up again, because I did present it all of those four ways of driving a stepper motor, and these are two of them, which is absolutely good. I'm very happy about it. I'm very I wish I can make another board for the half step driving, because these three these three modes of driving a motor, they are important. Every LED that you can see here that is lit, let me lower it, the speed. So every LED that you see here is actually a coil, or a group of coils, or some contacts on those coils. That's pretty much what this is, and is sending a signal to both coils here, and here is sending a signal to only one coil, I believe. Yeah, one by one coil, and here is two coils at once. And half step driving, I don't remember what is doing exactly, but I have to look it up. And yeah, but this, it should be interesting to have the third one with the half step driving, because that's also very important to have. And but first of all, I will have to link these two boards. This is in the future, very near future. The next step that I will make with this board, I'll have to link this board and this board together, and then make a switch that will commutate between one or another, and sync a bit more forward for the third one if I will make it. But if I will make it, I will have to sync from this moment when I'm making this switch. I will have to sync to make that switch 3 ways or even 4 ways, and you know, to cover all the angles, all the corners, pretty much. You know, to not leave anything. That's my idea, at least. But yeah, this is working fine, absolutely. It's having some problems there for some reason. I really have no idea why it's doing that. But if I smack it like this, yeah, this is working fine right now. Probably it's some wire somewhere. I have no idea. Or the diodes themselves. I believe there are some diodes, because I did. Oh, by the way, I have to light up to bring the light here. I've also used this scrap diodes here, which are very bad for logic. But for this kind of logic that is minimal here, only 2 diodes and not 4 like I'm having there. That is overkill what I have there for the logic part. These diodes didn't make a good. They weren't good there. So many, you know, 4 diodes per one module that I have there. But 2 diodes per one module like I'm having right now here is absolutely okay. It's absolutely fine. They are, and I was counting on this idea that there are a few of them and per module, and they behaved. They are behaving. They are okay right now. Do you like the fence that I make here? Yeah, look, this fence and this fence. Very cool, huh? All right, thank you very much, and see you later, I suppose. Yeah, I'm very happy that it's working, and like I said, absolutely unnecessarily complicated. Absolutely unnecessarily complicated. But it is what it is, huh? Life. Life. All right, I should have started with this module first, but I said, oh, maybe I can get it a little bit smaller. And it wouldn't be that much smaller than it is here, but a little bit, probably like, I don't know, that cheap. Actually, I have it here. We can compare it. By the way, I took out its LEDs that it was having here. And these are the LEDs that were here, and I took them out from here and mounted them there. So you can see that, yeah, it's kind of only this module, because this was originally planned like this, and it's kind of the same. You see, the same size, almost the same size. Maybe this is a little bit bigger than this one, but it's not really. It's retro. It is retro, very retro. All right, thank you very much. I hope you laugh like I am, and yeah, I'm very happy about it. I'm very happy about it. Fuck those chips, motherfuckers. Bye.